Hello, everyone. This is Sol Lederer of MetaMasks. I'm one of the co-founders of MetaMasks, and today we're going to do. Give me 1 second. I gotta pause something. All right. So I'm just gonna wait a couple of minutes only because I want to give other people a chance to join. But you are in the right place. Thanks for waiting for a couple of minutes. This is a class on coding your very first smart contract. So not only is it designed for people who are new to blockchain development, but it's actually geared more for people who are new to development altogether. So if you've never coded anything before, this is a session for you. We're going to dive into, well, as I said, I'm going to wait another minute or so, and then we'll get going. So just continue in just a moment. A couple things I should point out before we begin is that there is a little bit of a chat window on the right side or the bottom right of your video. So if you have any questions, feel free to pop those in there. Any comments, throw those in there. Also, I assume you are able to hear me okay. If there's any glitches on that side of things with seeing me, hearing me, maybe shoot me a note now. Otherwise, I will be good to go. Also, a little bit later, when I'm doing a lot of the coding, it might not come in very clear. So you would probably want to change your settings to have HD video coming in. So you can do that on the bottom right side of your player, the gear icon. If you click on that, there's a quality option, and just up that to the highest it goes. I think maybe 720p, if you can do the HD option. That's going to help a lot later. If you're on a slow internet connection, then I guess you got to stick with what's there. Okay, cool. So let's get started. Again, I'm Sol Lederer from MetaMasks. I've been teaching about blockchain development for 3 years now. Started out in a co-working space. I had a crypto-focused co-working space out in Brooklyn. And I was doing some workshops, some informal meetups over there on blockchains overall, different apps that are being released on Bitcoin and other blockchain platforms. And then we also had coding classes. And we really got started teaching coding classes with Ethereum. So Ethereum is by far has the largest developer network. And it's, I guess, by far the largest blockchain if you look at it in terms of the number of operators or the number of nodes on the network. So you have something like 15,000 machines that are running the Ethereum software versus in Bitcoin, I believe it's something like 2,000 or 3,000. So in many metrics, if you look at even the number of if you look at number of transactions, obviously the number of code that's being written on the blockchain, Ethereum is by far the biggest. So that's why we're going to focus on Ethereum. You're definitely picking the right blockchain to learn about. I'm going to divide this session into probably about 3 parts. So part 1 is just going to be a bit of an intro into blockchains and smart contracts, because if you don't have any introduction before, the rest of this is not going to make any sense. So I do have to give about a 15-minute intro into that side of things. Part 2 is I'm going to give an overview of programming in general. So again, as I mentioned before, this session is geared for people that are, if you're completely new to software development, you've maybe read about it or seen a lot about coding and you just had an interest in learning how to code, and you want to get started on the blockchain front, that's what this session is for. So I'm going to maybe give a 10-minute overview on software development. And then the final section, we'll do like 20 minutes on writing a smart contract itself. And I'm going to stop between those sections to answer some questions. So pretty much at the end of each of those 3 sections, I'll take some questions. And again, you can pop those into the chat window on the right side. So part 1, what is a blockchain? And I'm going to actually share some slides over here. And let's see if that works out. All right. So, one last thing I did forget to mention is later on we're going to use this app. It's a Google plugin called MetaMask. So while I'm talking here in the first 10 minutes, it's a bit of an intro. If you simultaneously, if you're interested in coding along with me, install this plugin. You just go to metamask.io and set up your account. And then if you go through these steps now, then once I get to this, to actually using MetaMask, which is going to be in about 30 minutes from now, you'll be ready to go. And I'm just going to try to improve the sound quality for 1 second, so just hold on. Okay, so the way I like to think about a blockchain is the best way to explain it is that it's a peer-to-peer app, very similar to BitTorrent. So if any of you have ever used BitTorrent before, where you're just moving files between other participants on the network. So instead of downloading files from some central server somewhere, instead you're sharing it among all the participants in the network. So instead of going to iTunes to download some music, you can shuttle music files between everyone on the network. And there are some other peer-to-peer apps that work like that. Skype, to some degree, also operates in that way, that when your call is, when you're connected to someone else, your call is routed through other people, other participants on the Skype network. And there are some other ones. OpenBazaar is a merchant marketplace that uses cryptocurrency, and it also operates in this way that it's a distributed or peer-to-peer version of eBay. So instead of you going to some eBay server, you're going to a store that's hosted on other people's computers. It's just another really cool app. If you're interested in distributed and peer-to-peer technology, you can check that out. So a blockchain is, again, a peer-to-peer app. Everyone is running the same software. You're not going to some central place like a Facebook or a Google. It does have one distinctive characteristic, or one thing that it does that peer-to-peer or distributed apps hadn't done before, and that is all the data, all the information that's on one machine is the same that's on everyone else's machine. So, and you're guaranteed about that fact. So I know whatever I'm looking at is the same thing that everyone else is looking at. And it's not just the data, but it's also any code, any executable programs that are within that data set is identical to everyone else. And if any program executes on one machine, or runs through some operations one machine, that will execute identically on everyone else's machine. So you have a lot of that kind of replication and redundancy, and it's all exactly the same across all the machines. Now, a smart contract is the term for those programs that are running on everyone's machine. It's maybe not the most, I guess, intuitive or the most explanatory, most descriptive term, because when you think about it, all it is a smart contract is a computer program that is running on the blockchain network, on that blockchain protocol. So I guess they get the name contracts only because they do have the ability to move digital assets of value. Specifically, it can move cryptocurrency. So in that sense, when you have some rules that are operating on things of value, so that in that sense, it is like a contract where you would have some legal contract that would say, on this date, this amount of money should be transferred from this party to another party. But of course, they are considered smart because now we're in an automated system. So this is the first time that computer programs can actually move money around autonomously. And when I say autonomously, I also mean that it cannot be prevented or stopped after the fact. Of course, you could always have a program at some bank that is programmed to move money from account A to account B under certain conditions or at a certain time. And in fact, when I had worked at Morgan Stanley, that was something that I did. I wrote software that would rebalance people's accounts based on their margin requirements and sort of the collateral that they needed in different accounts. So obviously that can be automated. However, at any point, the bank is in complete control of that process. So it can be turned off, it can be shut, could be changed. So if there's some movement of funds between bank A and bank B, there's no way to really automate that in a way so that, for instance, bank B is assured that bank A would carry out their side of the transaction. With a blockchain, on the other hand, you can program in these rules in such a way that it is some neutral third party, some neutral operator, so that neither bank A nor bank B can change things after their agreement. So they write the agreement up in computer code, and then once that is running on the blockchain, it cannot be changed after the fact. Those rules are immutable. I do have one kind of negative here on this list. I say they're expensive to run through because they run on every single machine. So in that sense, blockchain coding or smart contracts currently, they are very overhead intensive because they're replicated on so many machines. So they're expensive in terms of the computational use, which in turn means the monetary cost is also pretty high. So generally, think of smart contracts as programs that are, they can do things that can't be done with regular code, but nevertheless, you wouldn't want to rewrite your whole application on a blockchain. You would just want to have the critical components, to really make use of the distributed aspect of a blockchain. Anyway, I probably went a bit long on that. I'll try to get through some blockchain concepts, and then we can talk a little bit more on the coding side. So number one, we say a blockchain. So a block is really just a collection of different operations or transactions, which can be at a very basic level, sending cryptocurrency. That's kind of intrinsic to public blockchains, is that there is this intrinsic cryptocurrency. But another kind of transaction is just creating a new smart contract. So when you write a program and then you want to release it or deploy it onto the blockchain, that is another kind of transaction. And the third type would be if you're interacting with an existing smart contract. So invoking, or what's called calling, some smart contract out there, that is another kind of transaction. And when you call a smart contract, generally you can even call a very specific portion of it. So we'll see this later. That you can actually call a different, what are called functions, or a different operation. And even though everyone will run this code, in order for new transactions to get confirmed or really, sealed or settled on a blockchain, only one node or one operator is able to do that within a given time frame. And the way blockchains do that, we're not going to get into that because that's a whole nother session. on how blockchains are able to manage this, that sort of everyone gets a fair shot, but yet there is no central organizer that manages this, but just know that only one node at a time gets to do it. Publish a block, but once there is a block that's published, everyone else in the network will run through all the steps, all the transactions, and just confirm that everything within it is correct, and then they will add it to their own copy of the blockchain. And also note, final point, is that each block has a reference, a hash number, or an ID number of the previous block. So that's how the blocks are linked, and everyone can keep them in the proper order. This is just a little overview of what happens, or at least what we're going to be doing going forward when we're interacting with the blockchain using our browser. So I mentioned before, you should install this Chrome plugin called MetaMask, which takes the data or the information that we're going to be writing in our browser, and it pushes it through. It just sends it to some other server somewhere that are actually running the Ethereum code, or running an Ethereum client or an Ethereum node. And those nodes in turn will push out that information to everyone else who is running an Ethereum client. So it pushes out, that's the kind of the bottom half here. Well, it goes out into the blockchain network. The transaction first goes into this area called a memory pool, or mempool, where there's just a collection of transactions out there, but they haven't really been confirmed or packaged into a block. And then you have some miners. These are I guess you could think of them as nodes that are creating new blocks. They would pick a bunch of these transactions and try to create a valid block with them. I'm not going to get into what a valid block means, but once it is performed correctly, then that gets passed out also to the rest of the network, and then everyone can add it to their version of the chain. So I want to say, we could, getting back to the top half over here, we could run a node on our own, on our own machines, on our own laptops. I'm just going to do it this way, that we're taking another in-between step, this MetaMask plugin, because it just will make it a little bit easier for us all to get up and running without us installing the Ethereum software. But you can easily do that on ethereum.org. You can download it there. So I'll just take a quick break over here first, just to see sort of what, if there are any kind of questions, or if anyone wants to. Yeah, so if you have any questions up to this point in general, what I just talked about, on just in general how blockchain works, feel free to pop them in now. Otherwise, I'm just going to get into the second section, which is giving you a little bit of a quick intro to programming languages. And I know there's a little bit of a delay between when I'm speaking until when it shows up for you. So, all right, so it looks like we're good to continue. So when it comes to programming, there are a couple of points I want to make first. One is point one is that we're writing code in sort of like a very human understandable or human readable language, right? I mean, computer code is meant to be as close to natural language as possible. Like we do want to be able to write things like if this, then that. Obviously, when we write in that kind of high level language, it gets transformed into something lower and lower and lower until it gets to a low enough level so that it actually it's actually something that the computer can understand directly. And when I say computer, I mean the hardware, right? So ultimately, everything at the very bottom level, everything is happening on hardware. We have a bunch of these transistors, these integrated circuits. Integrated circuit, on your Intel, I don't know, i5 core, would have somewhere between 1 billion and 2 billion transistors on one circuit. And each of those transistors is essentially just an on-off switch. On just a second, just want to close some apps that were getting in the way. So yeah, so essentially we have a bunch of these on-off switches, and those on-off switches are controlled by computer code, which is just as ones and zeros, right? So for on and off, and nobody would program using ones and zeros because that is just far too cumbersome and it's just too close to the metal. So although at some point somebody had to start out there, just go very base level. So there's a layer on top of that that's called assembly, which is also pretty rudimentary. It's really hard to program in assembly. It's a lot where you're doing a lot of mathematical operations, like add up these two numbers and store that number on this particular spot in memory, and now get some other number. So it's very tedious too, and we don't program in assembly either. Some people do if you're building some new device driver. You're doing something very close to the hardware, you would do that. But then top of assembly language, there are, even starting in the 50s and 60s, there were higher level languages that were then converted down, which is called compiling, when you take something that is more readable and then convert it into something that is more understandable for the computer. So you're compiling a language, and there's a whole hierarchy of more and more sophisticated languages. I say that because I guess a lot of new programmers are a bit confused how writing this code actually translates into the computer doing something. The other thing is, when we look at the code, it's just going to seem like a lot of things are arbitrary, like there are a lot of symbols or a lot of formatting operations, or the syntax just seems really peculiar. And the truth is, to some degree, it is arbitrary because there are thousands of different programming languages, and some programming languages do some things one way, and other programming languages do things another way. So to some degree, it is arbitrary. But on the other hand, a lot of these kind of structures, or the way they're written, has evolved over the last 50, 60 years or more. Where the state of the art, where state of computer programs have improved, where computer scientists learned from sort of like the mistakes from the earlier generations and rewrote languages so that they're easier to write and then faster for the computer to process. So so that's really what I want to point out. It's like a little bit you have to kind of just go with it and not question the little syntactical parts of things, because that's just the way it is. And they'll make your job a lot easier when we actually get into the programming part. So we are going to program in a language that was developed specifically for Ethereum. It's called Solidity, and it's very similar to JavaScript. So if you've ever programmed in JavaScript, you'll find it very familiar, or even C and C++, Java. Syntactically, very similar. They needed a new language, though, because there are certain operations that you can do, or certain things or you want to do on Ethereum that doesn't exist on traditional coding systems. So for instance, like just operations to manage and send cryptocurrency. That's one example that you would need on a blockchain computer programming language. And note that Solidity is not the only programming language for Ethereum. It's just one of a whole set. There's Viper, which is similar to Python, if any of you are familiar with Python. And there's LLL and a couple of others. But note that all of these languages, they compile down, they transform down into something that is more understandable by the underlying Ethereum operating system. You can think of it. There's what's called the EVM, the Ethereum Virtual Machine, and that is something that is able to process those instructions or that code that you're writing for within Solidity or whatever smart contract you have. Let me just see if there's any, if you have any questions, feel free to pop them in. I'm not going to be covering Viper. There's a lot, one benefit about Solidity is that the vast majority of programmers on Ethereum are using Solidity, and there's a lot of documentation and information out there on using it. Viper is still a lot rawer, I would say. All right, if there are no questions, I will get into the main part of the session, is actually writing some code, a smart contract on Ethereum. And it's, again, we're going to start off very, very basic, and I'm just going to step you through every single line by line. And I'm going to start basic, and the stuff that I'm covering would not just be specific to Solidity. I mean, this is more just general to any programming language. Towards the end, we'll get into a few things that Solidity does that other programming languages can't do. But at the beginning, it's just a matter of we're going to program some very simple things, but happen to use the Solidity programming language. All right, let me just share my screen. Yeah, well, I just wanted to show you a little image, again, what I was talking about. We're going to be programming in some high-level language, something at the top, Solidity, and we're going to use this word. Later, we'll see that the program that we're using is going to say deploy, which will also convert our code into a lower level language, into something that the Ethereum system can. So it's like one program reading another program. I mentioned the EVM before, but I'm going to skip that for now. Let's just jump into the coding side of things. So for coding, we're going to use a website called rRmix. Let me try to make my screen a little more readable here. And I'm just going to double check what this looks like on your side. I guess. All right. Well, I'll tell you what. Let me know in the comments if you're having trouble with the screen, if there's anything I should adjust right or left. All right. I'm going to get to the questions in a bit, but first I want to just make sure that you can read what I have here. I'm going to make the font a bit bigger. So to start out with, we are on a website called rRmix.ethereum.org. So you can go to this URL up here, and that will bring you to a page like this. There might be some code in here. So in order to get rid of the code, you can just click on this plus icon on the top left side. And I'm going to just name this. I'm just going to call it begin. Doesn't matter over here what the name of this file is. So I have now a fresh screen over here. I am going to just pull up. This is a long contract here. I just want to copy this first line, and I'm going to paste that into this contract here. So I'm not ignore this first line for now. It just gets into something that's not really important for programming our first smart contract. It's something to tell the compiler. It's like an instruction for the compiler about this program that we are writing. So for now, you could just pop that in there, and we'll start writing the contract now. 1 second. Want to quit some other apps. OK. So in order to start our smart contract, you just start with the name contract. We are in, over here, this rRmix is called an IDE, which means an integrated developer environment. And one of the things that it gives you is that instead of you being a very, instead of being just a dumb text editor, this is like a text editor that understands what you're trying to do in here. And it knows that we want to write Solidity code. So it knows that the word contract is a special keyword of Solidity. So that's like a built-in word. And then we can just name it anything we want. So we're going to call it my contract. And you need this open and close brace over here. Again, this is something about the syntax. We won't question it for now. But this right here is now your first valid smart contract. All we're saying is that we have this contract with it by the name of my contract. It doesn't actually do anything. But on the right-hand side over here, you'll see there's a big right pane. If you don't see this screen, note that there are also these tabs up here in Remix. There's this compile tab, which compile, again, is converting that code into something, a lower level machine language. If there's a screen banner, that means that this code right here is a valid smart contract as it stands, which does, nothing. There's this run tab, and the run, I'm going to be using this for most of the session. There is this, well, it looks like a label here, deploy, but it's actually clickable. You can click that, and it will. What that does is it takes this code and pushes it out onto the blockchain. And when I say pushes it out onto the blockchain, it creates a transaction. As I mentioned before, every deploying code is just another kind of transaction on Ethereum. And it will send out that transaction. And once that gets into the chain, that means that this code is now sitting on everyone's machine on the blockchain. One other thing I want to point out up here is it says environment. The very top right, environment. There's a couple of options here, injected Web3. This injected Web3 means that it's talking to this Chrome plugin, as I mentioned before, called MetaMask. This little fox icon on the top right of my browser. So it has like this little interface that allows us to connect to the Ethereum network. We're not going to use the main Ethereum network here. We're going to use what's called one of the test networks. It's called Rinkeby Test Network. So if you want to switch between different networks, you just click on it, and then you switch to Rinkeby. By the way, if you're graphically, it might look slightly different for you than mine. This is the latest version of it. So if you're not on the latest version, this would look different. Before we actually deploy this to the blockchain, let's do something in this contract. Let's say I want this contract to store the number 10 in it. I don't know, for some reason, we just want to have the number 10 in it. I can say I'm going to have this variable called x. I'm going to assign the number 10 to it. I put a semicolon at the end. That's just the way the language is designed. After every instruction, after every operation, you need to have a semicolon. I also have to say what I'm storing in this number x, in this variable x. Is it going to be a word, or what's also known as a string? Is it going to be a negative number or positive? Is it some number? And indeed, we're going to be putting in, that's an integer, which is called the int for short. As you can see, it's color-coded again because this IDE recognizes there's something special about the word int. Unfortunately, it also colors numbers the same as these keywords like contract. So there's nothing special about the number 10, obviously. I could have just put 11 here too. I'm also going to say that this variable, I want it to be what's called public. So I add this other keyword in front of it, and that just means that any other program on the blockchain can read this number, can view it, like that has open visibility. It doesn't mean that if I don't have the word public, that there's no way to actually inspect the blockchain and see what's sitting there. This number is still exposed. It's not encrypted in any way, but no other program can access it programmatically, any program that's on Ethereum. So I'm just going to put in the word public because I want us to be able to sort of access it. So this right here is a valid contract. I'm going to just going to close some stuff here on the right. OK, so now I'm on the right side over here. There's this deploy button. I'm going to hit that. And as soon as I hit deploy, you notice this MetaMask window pops up. And yeah, I just want to make sure I didn't actually kill the screen, which has happened before. If you're having, again, any viewing problems, just feel free to pop that in the chat and I'll address it. So this is just asking me to confirm whether or not I wanted to send this code to the blockchain. It costs like 3 cents, and I hit confirm. If I go back to my MetaMask and I look at it, you can see that there is this, yeah, so right here, it just lists my transactions. And if I even click on it, it opens up another screen. This is a blockchain explorer, which lists all the transactions that are happening on the network. And it actually says that in this transaction, I created a contract that lives at its own separate address space. And it says I created this 31 seconds ago. So this contract is out there. rRmix also has the ability to read from this contract. So think of the left side as my programming environment, and the right side is sort of like a little interface, like a front end that allows me to send stuff off to the blockchain and then subsequently read from the blockchain. Down here, it says deployed contracts, which is the one I just deployed. It doesn't have any details, but you have to click on it to expand it. And once I expand it, then it shows this X over here, which is the variable that I have in this smart contract. If I click on X, that actually shows indeed it has the number 11 in it. So rRmix is helping me read from there. And I don't have to use rRmix. There are half a dozen other applications that you can use to read from the blockchain. And if you were to go to that particular address space or that Ethereum address, you would be able to read the number 11 that's stored there. So that's happening on the blockchain itself. We're using the Ethereum test network, but the same exact thing would be on the main network. And again, this doesn't do anything. We're just storing a number there. What we could do is, at least, this is so basic, we can't even change the number 11. Let's say we want that after we deploy it, we should be able to update the number to something else, maybe double it. So if we want to call this contract again, we create what is called a function. A function is just like a set of operations that are bundled together. And I'm going to call this one double it. It has this open close parentheses, which we're going to use later, and I'll get into what that is, what those parentheses are. And then again, we need this open and closed curly braces. So everything gets kind of, when you want to group stuff together, whether it's in a function or within a whole contract, they go in these curly braces. And what this is going to do is that any time I call or execute this operation, I want the X to now take on the value of X plus X. That's just a very primitive way of doubling X, just add it to itself. Note that here, the right side gets assigned to the left side. So this kind of equal sign is not really a straightforward equals. It doesn't mean that the left and right are equal. It actually is an assignment operator. It's saying, take whatever's on the right and put that on to whatever is on the left. I don't have to define it as int anymore because that was done at the top. Whatever is done outside a function gets executed once and only once when the contract is actually deployed or written to the blockchain. So this will get executed. Whatever is inside a function will not get executed at that point. The function only gets executed when separately we call that particular function. And we can deploy it again. Oh, over here too, I want to say that this function is public. Well, I think the public actually goes at the end. By default, functions are public anyway. You would have to specifically say that they're private if you don't want it to be accessible from the outside. But it just, rRmix gives a little warning that, hey, it's better practice to say that that's public. So I'm going back to the right side over here. I'm going to hit deploy this contract again. MetaMask pops up one more time. I'm going to hit confirm. And so what happens is, I don't know if you remember that image that I showed you at the beginning, there is a bit of a lag over here of maybe 20 seconds or so between that transaction being broadcast to the network and then to the time it takes for it to actually get packaged into a new block on the chain. So MetaMask is nice enough that it shows that, okay, that transaction confirmed. And now I have on the bottom right over here, I have now a second, I have like a second line here for another contract. Now when I expand it, you can see now I have another option here to hit that double it button. If I click on X, by the way, it shows the number 11. Reading from the blockchain does not involve a transaction. It's very easy to just read numbers off the blockchain. But if I want to change something on the blockchain or invoke some kind of operation, that is a new transaction. So as soon as I hit double it, MetaMask should pop up. And sure enough, MetaMask pops up. And I'm assuming you can see this little overlay window that's coming up on my screen. I'm going to hit confirm. Once that gets confirmed on the blockchain, then when I hit X, the number should change to 22. I also want to point out that it shows over here, this might be confusing. It says int 256. Int 256 is just another way of saying that this number is an integer, but it's the 256 represents the size of how big this integer is allowed to get. And it's allowed to get to be 256 digits long, or rather bits long. So it's 256 digits in binary. So now that this transaction has confirmed, when I hit X, the number now has changed to 22. So this is something, that operation, all that, changing the number, that has happened on the Ethereum blockchain itself. As you can see, it kind of takes a bit of time to run through every step when we're deploying it to the real blockchain, because there is sort of like that 15-second delay or so between every transaction. So to make this a little bit faster, what I'm going to do is on the top right over here, rRmix has an option to change. You can change your environment. So we can change it, instead of it being injected Web3, meaning that that's something that MetaMask is like, it's telling basically that this browser, this website is talking to MetaMask, which provides some hook to communicate to the blockchain. I'm going to switch it to the first option, JavaScript VM, which means that rRmix itself is able to mimic what the blockchain would do behind the scenes. So within the browser itself, it pretends as if there is the Ethereum node or Ethereum client that's running behind the scenes. So we're going to use that because it's going to be a lot faster. It's instantaneous. We don't have to wait for a new, essentially it's able to make blocks immediately because we're just doing it ourselves. As you can see, if I hit deploy now, I get this, it's deployed immediately, and I can hit double it a bunch of times. And now it should have, have 88 because I hit double it 3 times. Okay, so this isn't super interesting yet either. To make it more interesting, what I could do is I can also send in, what if I want to send in information to this function? So if I want to pass in a number, let's say we'll call it y, and I want to say make x to be twice the value of y. So if I want to send information into a function, the way I describe it within the language itself is to say, I just put some variable. I can say y. I can call it anything I want. I could have called it, whatever. That is a valid variable name. I have to say what type of data is coming in. And again, I'm getting an int that's going to come in. I'll just switch this back to y. So now we're passing in the value of y. And at this point, I'm going to say I want x to be twice the value of whatever gets passed in. This is the multiplication symbol. So you can see the star symbol, that's the way, or asterisk, that's multiplication in many, I would say most programming languages. So now I can redeploy this. Again, I'm going to be, whenever I say deploy, I'm up on the right side over here, hitting the deploy icon, and the latest version of the contract will come at the bottom here, and I have to click on it to expand the the two operations. So if I click on X now, we have 11. But notice in this double it, now it has this little input field. I can put in some numbers. I can type in 100. Now I'm typing 100 on the bottom right here. And now if I hit double it, that's a transaction that is happening on the blockchain, but not really the blockchain. It's really just within Remix behind the scenes. And now if I hit X, I should get 200. And sure enough, I get 200. 1, 2, 3, 4, double it, and then I'll get to 4, 6, 8 down here. So that's, we're doing something. But very often in programming languages, you want to only change things or do some operation based on some other condition. Like if this is true, then do this, otherwise do something else. So you have a lot of these control flow structures. You could say while this is true, keep doing the other thing. So the way we do that first control structure that I mentioned, so we can write if let's say if y is an even number. So the way I can write if y is an even number in kind of mathematical terms, I can say if y mod 2 equals 0. Mod is an operator which is represented here by a %, which means that if you divide by 2, what is the remainder? So what is the remainder of dividing y by 2? And if the remainder is 0, that would mean y is indeed even. If the remainder is 1, y would be odd. So I want to say that if this condition is true, and I want to point out here also that I'm using an equal sign. So equal in this case actually means that the right and the left side is indeed equal, like I'm making that condition. So if that's the case, then I want to double the value of, I want to say x is twice y. Otherwise, which we call else, I want to set x back to 0. So this is just a very simple operation here. And notice I'm just doing these little indents for readability. This is just kind of the, I guess, best practice, how to write the code. This could all be combined. I could actually combine things on different lines. The spacing and all that doesn't matter because the computer knows kind of where statements end based on these semicolons. They could have used, some languages may use a period, some may just not have semicolons and just use a new line altogether. Just go on to the next line and we know we're done. But it's kind of has benefits for various reasons to use some delimiter like a semicolon, and that's why Solidity does it. And so we can try this out again, going back to the right to deploy, have this new contract down here. I'm going to put in, so let's say if y is 1,000, which is even, I hit double it, and again, I'm on the bottom right over here. And now if I hit x, I should get 2,000, which I do. But if I put in 1111, a bunch of ones, then hit double that, and now x should be reset to 0 because it failed this condition over here, whether or not these two things are equal. We can make this a little bit more interesting. By the way, since I have so many contracts deployed here on the right side, I can remove them. I could just hit this garbage can. So I'll clear that all out. So to make this a little bit more interesting, what if we want to say that we only double the number, we only double x is when let's say y, or I want to say that the address of this contract, what I'm going to do is I'm going to say, not the address, but rather the person who invoked this operation, whoever invoked this transaction, whoever is calling this function double it, just repeating the same thing 3 times. If whoever called it has a particular address, and what I'm going to say is my account over here on the top right, under environment, it says account, and that says it has part of an Ethereum address over here. And this is the address from with that's my address, and that's what I'm using to deploy code. So anytime you deploy anything or send any transaction, there's always a from address, and this will be my from address. And I want to copy it. There's a little copy icon here. I'm going to paste that in this if condition over here, and I'm going to say that if msg.sender is equal to this address. msg.sender means it stands for message.sender. So the message itself is a built-in variable. Think of it like a variable like X, but the language just gives it to us behind the scenes. We don't need to declare it or define it directly within our smart contract. It's just always there. So and it has different sub-properties to it. One of them is sender. So it refers to the actual transaction that we're in right now. That's the world that we're in right now. This transaction, whoever the sender is, sender refers to an address. If that address is indeed my address, the one the account that I'm sending it from, only in that case do I want to double the value of X. So essentially what I'm saying here is that the address that deployed the contract is the only one that is now able to change the value or increase the value of X. Let me deploy that, and we'll see that in action. So I hit deploy, and now when I do double it, this will work because we have now 222. It works because I'm the one that deployed this contract. I'm doing everything from within this address. But I can change with who the sender is. Up here on the top right, rRmix gives me the option to use some other accounts. So if I switch this second account over here, and now if I try double it, I'm going to do 888, double it. Now when I hit X, this should be 0. And indeed, it's 0. And the reason why it's 0 is because now the sender that called double it was not the one that started C835. It's my new address here starts on the top right. You can see starts with 0x147. Everything starts with 0x. That's just denotes that this is an Ethereum address, base 16 address. So we could do it that way. There's a way you can get even more sophisticated by saying, it doesn't have to be hard-coded. Although I do see maybe I could just take a minute to do it the more sophisticated way. And that would be if I want to say the message.sender is equal to the owner. Now, owner is something I'm just making up. That's my own variable. Obviously, I haven't described what owner is, or I just want to make it clear that I'm making up the word owner. So I can as easily say that the one who deployed this contract. As long as it's all one continuous word, that is a valid variable. But of course, we have to describe what is the one that deployed. What is that? So I'm going to say this is a variable of type address. Address is something specific to Solidity, that you have this special data type that is just designed to store an address. And I'm going to say at the top, and remember, this line gets executed when the contract first gets deployed. I'm going to say over here should be a message.sender again. So the one who deployed it, one who deploys it, we can get that address by calling message.sender at the very beginning. And now later on, when this function gets executed, I can refer back to this address that was stored before. So that looks right to me. We can try that again, deploy, and right. So now if I hit double it, hit X, that indeed works. But if I were to switch my address, maybe go back to this first one, and I hit double it, this should not work. This should be 0, and indeed it's 0. So in this way, you can sort of grant access, do special things for the user that deployed a contract versus anyone else, so that you can differentiate different parties within a smart contract. I see we're kind of running towards the end. I just want to take a quick look at the questions over here. Feel free to pop any of them in here, because I think we're going to conclude now for this one. I do want to point out that I'm going to continue a webinar that is going to sort of take this and get a lot more advanced, and we're going to cover things like voting on the blockchain and doing that with what's called commit reveal voting. So it's going to get into some really neat things about using Solidity and coding on a blockchain. I'm actually going to pop the link in over here on the right side. This is to our Teachable, to our training platform. So if you go to that URL, and you can actually sign up for that, we're actually running, just for today, the price is $15. Normally it's $30. So if you are, if you want to take your coding skills to the next level, highly recommend that you get on board with that. Just going to be $15 for today. Also, as Benjamin pointed out, check out our newsletter, sign up for that. We have always constant news that's every week. We have a few articles around blockchain, learning the latest about what's going on. Follow us on Twitter. We also point to different news stories outside of stuff that we write ourselves that we find most interesting and relevant. So between those three aspects, our blog, the newsletter, Twitter, you should be pretty set on sort of the knowledge out there and what's happening in the blockchain space. I'd hope to see you again. And again, that next class is going to be, I believe, September 14th. Same time, same length, and I'll see you there. Let me just see, is there a way to make rRmix save the contract across reloads? So Harry asked that question. Indeed, you could. Generally, it does save it. And so if you notice that it saves it in your cookies, sometimes your cookies can get wiped out, or sometimes they release a new version of rRmix and you'll notice everything is gone. But there is a way you can save it locally to your machine too, so you can never lose it. There is some, let's see, on the top left over here, it says add local file to browser storage explorer. So basically you can connect your local file system to rRmix and save it there. And let me know if anyone else has a question. Now's your chance to pop it in. We just have about a couple minutes left here. This recording will likely stay up unless we decide not to. So I guess I don't really have a definite answer there. Can you create a proof of stake system with an ERC token on top of the Ethereum network, or will a separate blockchain be needed? So it's a pretty good question. You can pretty involved question. Well, I will say that Omise Go is doing just that. Although it depends kind of what you mean by I mean, to some degree, yeah, there is a separate blockchain that is pegged to the Ethereum blockchain. So you can't make proof of stake just on its own running on Ethereum. I mean, right now, Ethereum itself is not proof of stake, even though it's moving towards that soon. The only way you can create proof of stake is you have separate nodes that are doing it. All right, I think that's a wrap, everyone. Maybe I'll actually just turn off the screen sharing for a second here. Can stop that. Yeah, so enjoy the rest of your day, everyone. Welcome to Ethereum Coding. I hope that was a good start for you. And again, stay in touch and hope to see you again. And I'm Sol Lederer of Blockmatics. Bye-bye.